What's up, fellow gamers? This video is part 3 of a series detailing enhancement pack creation for the Mesen NES emulator. This is going to cover custom animations and adding frames to a walking animation using frameRange condition functions. We're going to show you how to take a standard walking animation that looks like this and customize it with additional frames so that it looks like this. And before we get started, let me just get this out of the way. I know enhancement packs, or HD packs, can be a bit controversial at times. While some may view these enhancements as a good excuse to revisit a game from childhood, others may not be so keen on the idea of messing with retro graphics, gameplay, or audio. In fact, I dare say there are some that may even detest the idea of an enhancement pack that adds frames to an animation.
Doesn't this guy completely misses the point of retro aesthetics? Doesn't this guy know that 8-bit Samus is supposed to look like she's having a seizure? Anything other than HD packs? Congratulations, you just found a way to make HD packs an even worse than unsubscribe.
Just hear me out here. Before you ask yourself,
but why?
Maybe, just maybe, we should be asking ourselves, why not? So let's do this. First, you're going to want to make sure to download Mesen and make sure to grab the latest version from MKWong98 in the description of the video below. Also, make sure to have the ROM that you intend to work on ready. I won't be able to help you with this portion because certain people will come for me. FBI, open up! So once you've downloaded and installed Mesen, you can navigate to Tools, HD Pack Builder, and I'm going to start a pack just to establish the basics. If you want more help in this area, watch part 1 of the Mesen Pack Building series. I'll have a link in the description of the video below. So once you've created your pack, there should be a folder inside your Mesen directory called HD Packs. We're going to click on that, and click on the game that you'd like to edit. In my case, it's Castlevania. And then click on the highres.txt file. This is the file that actually instructs Mesen how to replace graphics. So next, I'm going to insert a picture file into this folder right here, and I'm going to insert some text that I pre-prepared before this video here. Once I've done that, I can explain how both work, and then you can create your own. So the picture I'm going to insert here, I named it myself and called it File Animation. Again, I'll explain that in a minute. And I'll open up the highres.txt file again, and there's some text I'm going to want to insert that I also pre-prepared, and I'm going to want to do that right here. We're going to maximize. I'm going to highlight what I just added so I can explain how it all works. This first line right here just corresponds to the picture file that I just added. These next 3 lines merely are notes for myself, and Mesen knows not to read them because of these hashes at the beginning. So if you have any notes you want to add to your highres.txt file, just make sure to put hashes at the beginning. These next 4 lines correspond to the actual animation we'd like to add. Now again, this is a very simple example. The walking animation is a bit more complex, but it'll be easier to explain once I've done a simpler example. If you've watched one of my previous videos, you may remember that a condition is an if-then statement. The 2 lines on the very top pertain to the if-then scenarios that I'm going to use. The next 2 lines pertain to the graphics that are actually getting replaced. Okay, so going back to the if-then statements in more detail. This highlighted section here indicates to Mesen that we're going to be using a condition. This is the name of that condition. You can call it whatever you want as long as you remember it later. This indicates to Mesen that we're going to be using the frameRange condition function. Now when you play a game, it's made of a series of frames that occur in quick succession, and this takes advantage of that. This number indicates the total number of frames in the scenario you'd like to define. And this indicates how many of those frames you want to be true for this scenario. So, in other words, frames 10 through 20 are true for this scenario, and frames 0 through 20 are true for this scenario. Now, that becomes more important down here. This information on the far right indicates to Mesen that a graphic replacement action will occur. This indicates the conditions under which that must happen. So, in other words, when this condition is true, this graphic replacement happens. When this condition is true, this graphic replacement happens. Now, the order of these is important because Mesen works by reading from top down. So in other words, you want your more restrictive conditions on the top and your less restrictive conditions on the bottom. So for frames 10 through 20, this is true, and then whatever's left will be true. In this case, that's the least restrictive condition, so that means frames 0 through 10 will be true for this graphic replacement here. Now, let's talk about the graphic replacement section in more detail. This first highlighted section indicates the numbered PNG file we'd want to reference from our overall list. In our case, we added a custom PNG file here, which is numbered 8th on the list, from going top to bottom. This next section is the graphic identifier of the tile or sprite that you would like to replace. It's actually pretty easy to obtain this. All you have to do is open Mesen, go to Debug, EPU Viewer, and we're going to be animating this bottom floor section here. So you can just grab one of these, right click, hit copy tile, highlight, and paste it in there. These next two numbers indicate the X and Y coordinates of the graphic information that you're going to use to replace what's normally here in the game. So for frame 2, the graphic information is located at point 0, 0. For frame 1, the graphic information is located at point 8, 0. You might be wondering where I obtained those coordinates. Well, if we go back to the file that I just created before this video, I'm going to zoom in here. Now, I'm working on a graphic pack that has a scale of 1, and what that means is that the scale is the same as an NES game. And that's important to note because NES games have boxes and sprites that use 8x8 squares, so my replacement graphics are also going to have 8x8 squares. You'll notice here, if I click and drag, that this is made up of exactly 8x8 pixels for my number 1. Same is true for the number 2 over here. So, in other words, this number 1 will be one of the frames. That's located at point 0, 0 right here. If I click and drag, Photoshop here should be able to tell me how far to the right I need to move. In this case, it's 8 pixels to the right. And so that's why the location is 8, 0 for the other frame. Okay, so now let's go back to the highres.txt file. This last number here indicates the brightness. Typically you would use 1 unless you're doing some type of fade effect, which you can use values between 0 and 1. And the last letter here can be a Y or a N, depending on if you want this to be true for all of the palette colors. The palette information is indicated here. That indicates what color your graphic is. In this case, I'm not really going to be working in multiple colors, so I'm not going to really worry about this too much. Alright, so to recap, these are two conditions we're going to use, which are if-then statements. This is going to be true for frame 2, so that means that for a portion of our frames, we're going to use the graphic located at point 0, 0. And for this one, whenever frame 1 condition is true, we're going to be using the graphic at location 8, 0. So let's see how it actually looks in the game. In order to check that, you can just hit File, Save, and go over to Mesen, and close it. And then reopen Mesen back up. So before I open it, I'm just going to go to Options, Audio, and disable the audio so you can hear me better. Okay? And another nice thing about Mesen is that it saves states where you can just get right back into the game where you left off rather than going to File Open. So we're going to do that, and I'm just going to hit this box here to get back into the game. Alright, and you can see it works. Now at the very bottom you can see that it's jumping between the numbers 1 and 2, and I actually just realized that they don't really look that far from one another, but you can get the idea that basically it's jumping between the 2 frames in that file that I showed earlier. And believe it or not, that's actually all you need to know in order to insert custom running graphics as well. It's the same principle, which I'll talk about now. Okay, so let's jump back into the highres.txt file. And we're going to get rid of this because we don't need it any longer. I'm going to paste some information I prepared earlier. Okay, so it looks like there's quite a bit here, and I'm going to explain all of it, but pretty much it just mirrors everything we've done so far, just on a much larger scale. Now, in the previous case, I actually had 2 frames. Now, for this walking animation, I'm going to have 12. That's why there's 12 lines here. So the only difference is that there's just more of these conditions. And before I had 20 frames as far as the overall scenario. Now you'll notice that number has been increased to 36. You can actually experiment with different speeds. If you actually have a larger number here, you put in something like 60, and then you have regular increments that lead up to that 60 amount, it'll go slower, and as the numbers get smaller, it gets faster. If you scroll down to the actual graphic replacement section, you'll notice that there's a lot more line items for the walk frame 12 condition. The reason for that is because there's a lot more graphics that we're replacing. See what I'm talking about? We're going to go to Mesen, and we're going to go to Debug, CPU Viewer, and we're going to go to the Sprite Viewer this time. And I'm actually going to start the game, and we're going to actually move the character so that he's facing the direction I want him to face. That's better. Now let's go back to the PPU Viewer, and you'll notice if I drag my mouse over to the character, it'll highlight a section, but it won't be an 8x8 square anymore. Now I'm not sure why, but this behavior does change game by game. But with this particular game, if you right-click like before, and hit Copy Tile HD Pack Format, just put it in here, notice that it pastes 2 lines rather than just the one. It's because there was 2 8x8 squares on top of one another. So this top section pertains to the top of Simon's head here, and this section pertains to the arm here. Occasionally, you might run into scenarios where it doesn't paste 2 lines like that. There is a workaround you can do if that happens to you. What you can do is go to CHR Viewer instead, and if it looks scrambled up like this, one thing you can do to try to make it look better, if you hit this box here, it might clean it up to make it look a little bit more recognizable. And you might need to change these colors here so that it looks the way you want it to look. And in this case, I wanted that kind of gold color. And you can do the same thing as before. You can right click and hit Copy Tile HD Pack Format, and it should match up with this top section here. Now, again, this is one situation where I don't know why it's different, but occasionally what you'll have to do is change the 0 to an F just to make sure that the pack recognizes it going forward. You'd have to do the same thing for the arm here. Copy, paste, and again change that F. You don't need to change that 0 to an F for some reason with this tab, but you do for this one. And again, I'm not sure why that's the case, but hopefully you won't even need to use this tab if this one works the first time around. Now let's look at the highres.txt file and the PP viewer at the same time so we can see what's going on. If you scroll down, you'll notice that, get rid of these duplicates here. Okay. Notice that this pertains to this here, this pertains to this, and if you go down in a regular pattern, all of these graphics equal all of the squares that comprise this animation here. You might wonder why there's multiple sections for this walk frame 12 animation. The reason is because if you move forward just a little bit, sprites have changed. And if you move forward just a little bit more, sprites change again. In this case, there's actually 3 walking frames, and so we have to replace all of those to achieve the effect we want to pull off. Now, at this point, you might wonder where I obtained all of these X and Y coordinates. That's where the graphic that I received online actually comes into play. And I'm just going to have a little plug here for this DeviantArt user here. They actually have gone through and added frames to a number of popular characters. There's Mario here, there's Ninja Gaiden, Metroid, and this is the particular one that we actually are going to use for this pack. So what I did is I downloaded this file into Photoshop and took each of the frames in that 12 frame animation and just evenly spaced them out. by 16 pixels. Then I drew another layer on top of that, only as a reference, so I could see where all the various x and y coordinates should be. And so I translated each one of these frames to the highres.txt file. So let's see if we can look at an example. I'm just going to move this over here, and this over here. Okay. The way I organize this is frame 12 is going to be on the very far right of the overall PNG file that I have. So I'm going to scroll here. It's going to be this one here. This is going to be frame 12. And the pattern that I used to lay this out is I started on the very top and I selected the graphic for the face here, put that on top, move to the hand, put that here, the knee goes here, and I just had a regular pattern, so it made it easy for myself when I was assigning x and y coordinates. And to actually obtain those coordinates, you can use this tool here, and if you left click and drag to the right, it'll actually give you x and y coordinates in the box there. So you'll notice that it should be 176 and 0, and that corresponds to here. And 176.8 is here, and so forth. And then for the 11, that corresponds to this one. So as you can see, there's quite a few to replace, and the more frames that you have that you'd like to replace, and the more frames that are existing in the game, they kind of multiply one another, so you can see how this kind of grows exponentially depending on how many you want to do. Now, one additional step that's needed is now that I've inserted all of that text into here, minimize this, and actually need to put this graphic that I worked with into the pack. So as I said, I prepared that elsewhere, and so I'm gonna plug it in here, and you'll notice it's a different name. I'm just gonna copy this text here back into my highres.txt file, scroll up, and I'm calling this Simon Walk Upgrade. And then hit File Save. So now that we've done that, let's go back into Mesen and see how it looks. So we'll go right back here, open up Mesen, and click on the screen. All right, and the frames are inserted. Now you'll notice, it looks great when the character's moving. It doesn't stop. And the reason for that is because we need to add one additional condition. Make sure that the animation only works when you're pressing a direction. So to fix that glitch that we introduced, we're going to go back into our HD packs folder, go to the highres.txt file, zoom in a little bit here so we can see it, and we're going to add in one more condition. All right, so I'm not going to speak about this a lot because I think really I could dedicate an entire video to it, but at the very least I'm going to say this is something called a memory check, and what this does is it looks at the internal workings of the game and looks to see how it's actually operating. And in this case, I'm calling my new condition Simon Not Still. It's looking in the memory of the game specifically at address 584. And what this means is it doesn't mean equals, it means not equal to 0. And what this is saying is that whenever the specific address 584 in the game does not equal 0, then this is going to be true. And so to apply this to all of the other frames that we've already established, a really quick way to do that is to hit Control-C to copy this bracket here, go to Edit, Replace, that bracket. So anywhere we have that bracket, we want it to say Simon Not Still and if we hit Replace All, now it has the condition. All right, so not only is whenever walk frame 12 true here, this also needs to be true in order for this graphic replacement to work. So you might wonder, where in the world did I come up with these values here? And this is where it's really helpful if your game is well documented. Fortunately, in our case, Castlevania is well documented. So to basically look up the information that's helpful for memory checks, just basically find the game using Google. So you can go to Castlevania RAM map. We're going to click on the first option. If I scroll all the way to the bottom, you'll notice a section here that says Simon's substate. Now this is perfect for what we want to do, because basically currently the animation is working all the time. We don't want it to work when Simon is still, and that's what this basically indicates here. Address 584. It knows that when the 584 value is 0, Simon is not moving. That's perfect for what we want. So in this case, if you go back to the example that we have, what address 584, whenever the address is not 0, we want the condition to work. So let's make sure to go to File and Save to make sure we saved it. Go back into Mesen and restart it, and see if adding that additional qualifier makes sure to shut down that animation for whenever Simon is still. Okay, so Simon's not moving. Perfect. So now it works properly. So now we can enjoy Castlevania in all of its 12 walking frame glory. Just as a little side note, if you're attempting this with your own game, you're likely to run into some other glitches and challenges along the way that are different from Castlevania. In fact, I did come across other glitches with Castlevania that required fixing, aside from what was covered in this video. I won't cover every single memory check that I added to get rid of those pesky issues, but I will upload the final resulting pack for Mario, Metroid, and Castlevania. If you're interested, feel free to look them over, and I encourage you to try one of your own. Most challenges should be able to be overcome by using the general principles I've outlined in this video. So, I hope you found this video useful. Have fun making those packs, and as always, happy gaming!